Hello students, we have exercise problem 7.25 of chapter 7 alternating current in this video. The question is, a small town with demand of 800 kilowatt of electric power at 220 volt is situated 15 km away from electric plant, generating power at 440 volt. The resistance of the two wire line carrying power is 0.5 ohm per kilometer. The town gets power from the line through 4220 volt step down transformer at substation in the town. From this situation we have three questions. First one is estimate the line power loss in form of heat. Second one, how much power must the plant supply assuming there is negligible power loss due to leakage. Characterize the step up transformer at the plant. So let us understand the problem first. Uh, Here power is produced at one part and it is to be delivered to other part through two wire line. So the power which is required, let us denote it by PR, is 800 kilowatt, that is 800 into 10 raised to 3 watt, and the voltage required is 220 volt. The distance is 15 kilometer and the resistance per away from the electric plant which is generating 440 volts. So the power produced, voltage produced is 440 volt. The resistance per unit length is 0.5 per kilometer, and the transformer at the output is 4000 volt to 220 volt. So the condition is like, you have a power plant, say power plant, and it is connected to a town. Say here is your town, and you have two transformers. First transformer is the one which is converting the produced 440 volt into some high value, and second transformer, let it be transformer 1 and let here be transformer 2. The second transformer is doing the other job. It is converting high voltage into low voltage. What the second transformer is doing, it is converting 4000 volt into 220 volt. So what should be done here? 440 volt should be converted into which value of voltage? Question 1. How much is the transmission loss? That also we'll need to figure out. So how to start? We know that the total resistance from these two data, we can figure out that if half ohm is for 1 kilometer, for 15 kilometer the total resistance will be 7.5 ohm. Okay. Now, how much current these transmission lines are actually carrying? So, we know that the voltage at which the supply is done is 4000 volt. So, power is equal to I square R. So, if I take power to be 4000, sorry, no, sorry, I think we have to take power is equal to V into I because we know the power required. So, if I take power required to be 800 kilowatt, and then if I take the voltage to be 4000 volt, I'll get some value of current. I am carrying out calculation here because I will need the value. So how much voltage will get? It will be 200 ampere. very large current, very large current. And so the power loss due to transmission line is I square R. Look at the value, 200 square into 7.5. So I made one more mistake. As it is two wire line, we will have to multiply this 7.5 with 2 because there are two such wires. So I'll consider 2. And then the answer is 15 into 2 into 2, that is 600 kilowatt, I suppose, is the answer. So now there are two things. The power which we want in the town is 800 kilowatt. The power which is lost during the transmission is 600 kilowatt. It means that the job of this power station is to supply. Power supply should be power required plus power loss. That is 800 plus 600, that is 1400 kilowatt power. If it supplies, then the town will get the required amount of energy. Okay. One more thing. At this transformer, we want 400 volt. But this transmission line will also consume some voltage. How much is the voltage consumed by the transmission line? So the voltage across transmission line is equal to IR. How much is the current passing through transmission line? 200 ampere into resistance 15 ohm, that is 3000 volt. So at transformer at T2 we want 4000 volt. 3000 volt is already taken up by transmission line, so the output voltage V out at transformer T1 should be 7000 volt. So if this transformer gives 7000 volt, then we'll get 800 kilowatt power as output from the secondary transformer, and that is the desirable value. So what is the answer of C? Characterize the step-up transformer. The transformer should be able to convert 440 volt into 7000 volt. What is the answer of B? How much power must the plant supply? The plant must supply 1400 kilowatt. Answer of A, estimate the power loss in heat. What is the power loss in heat? This is the power loss in heat. Okay, so this is the answer of B. This is the answer of A, and 440 to 7000 volt. This is the answer of C. So that is all about 7.25. Thank you.